All right, hello. My name is Maximus Laurent, and today I will be going to be presenting to you me and my wonderful team members' wooden toy project called Learn to Spell, the wooden computer with blocks. So, a little bit of background and motivation for this wooden toy project is why do we choose a wooden computer? Well, a wooden computer design is unique, easily recognizable, and it's simple. Child can look at the shapes of the computer and analyze it very easily, since it's just squares and rectangles. And a little bit more about our toy. So, our toy has 16 letters attached to the bottom, the quote unquote keyboard of our wooden computer. And the child can use those letters and cubes to pick them and stick them to the base, the main screen of the computer to spell words. And this will be very critical to language development, reading, and writing skills for these young children. And spelling a word gives the child a sense of achievement, right? It gives the child a sense of happiness that, yay, I was able to spell a word with mixed and scrambled letters. I made something out of nothing. I want to keep doing this and keep feeling that sense of achievement. And and that sense of achievement will keep the child actively engaged with the toy and learning. So a little bit of competitors on the market. We have the Brain Builders, the Play 22 wooden train tracks, and the wooden building blocks. These were three of the main inspirations on why we chose the pick and stick strategy for the wooden cubes, because these are all very successful toys and they all include putting together wood and creating something out of nothing, like the train tracks. Like you create a train track out of nothing, out of a bunch of scrambled train tracks. And then we have the wooden blocks. And the wooden blocks also, the child is able to make something out of nothing. You can stack stuff on top of stack these wooden cubes on top of each other to create castles, houses, and anything the child wants, and it gives them a sense of achievement. And then the brain builders. The brain builders also is just a stack. It's a stacking wood toy that the child is able to just do whatever they really want, free range. But the take along toolkit and the cutting play food set are two of the major ideas on two of the major toys that inspired our wooden computer. And this is because these are two toys that mimic real life things like the computer and spelling, and it secretly teaches these kids things about the real world while the kid has fun playing with these toys, not knowing that that these are actually critical development moments that they're experiencing, such as the cutting play food set. Child is learning how to use a knife and how and what to recognize in the kitchen and basic fruits and cutting fruits in half with knives. And the take along toolkit, again, it's just a simple one kit where the kid uses wooden tools like wooden wrenches and wooden screws and just things you would see in real life. So the project scope for our toy is again to enhance cognitive development. And we're targeting kids around ages 3 to 5 years old because this is around the time where kids learn how to spell simple words and learn how to read simple words. And this all goes hand in hand with promoting language and spelling skills. So for our wants and constraints, this may look like a lot at first, but I will narrow this down for you. So we'll start with the constraints. So for the safety, we want our toy to pass the ASTM tests. Basically, all this is a series of tests that which we'll get into later in this presentation, but it's just a series of tests to ensure that the toy is safe to get put out for market. And then our size, it had to be around 8 pounds max, but our toy was around 4 to 5 pounds, maybe a little give or take a little bit less. And these are the dimensions of our toy: 7.75 inches by 7.25 inches by 1 inch. This is well within the size of of the box that we were given for this project. And our manufacturing had 3 manufacturing process steps, which I'll get into later. And we had a budget of $20. And this budget was well met, as we only spent around $11 on extra materials, and those materials were just the Velcro strips and the wooden blocks. And moving on to the wants, we want it to be age appropriate, obviously, for 3 to 5 year olds. And another main and huge standard for our group was to be consistent with the Melissa and Doug brand. We want it to be mostly wood and educational children's toy, which our computer is 95% wood outside of the hinges, and it is an extremely educational toy that can teach kids how to spell and read. And we want it to be engaging, obviously. We want our toy to be engaging, and our toy can have unlimited playtimes. It's spelling, it's practicing how to spell and having fun with it. So you can have well over 10 minutes of play with this toy. And again, going off the skill building, we want to enhance the skills of reading and spelling, which may seem repetitive at this point, but I promise you it is enormous factor. It is an enormous factor in our toy and an enormous inspiration for our toy. And it's also inclusive for all genders. Anybody can enjoy this toy. So we have some initial concepts. We have our play phones, computer with blocks, and the ball launcher game. So the first idea, the play phones. It's another simple idea that the child can actively engage with. However, there's not much educational value that comes in with a play phone, right? There's only so much you can do with a play phone. And we just figured that it wouldn't be worth our time trying to figure out a way to make it an educational way. And then the ball launcher, it was a fun idea. However, we had too many concerns with the choking hazard aspect of the ball launcher alongside with just the competitors on the market, right? There's tons of ball launcher games on the market that you can find. So we wanted to come up with something original. So we came up with this computer with blocks. And that was our final design selection. So this is a rough sketch. This was our initial design. This is our first sketch we ever came up with. And it opens and closes with a hinge, obviously, to fold. It has 16 letters down here. It'll have 16 slots for 16 letters. And basically, the vowels will all be in a different color than the rest of the letters, so the child can recognize that the vowels are significant. They're significantly different than the other letters, and they are significantly more important to spelling simple words than the other letters, and they need to recognize those vowels. So we have 16 letters with all the vowels, and it opens and closes with a hinge, and we have a mouse for aesthetics. And the mouse has no impact on the toy itself. It is just there for aesthetic reasons. So here's our CAD design of our toy. And this is exactly what we pictured, right? We have 16 slots down here for the toy, for the computer, I'm sorry. And the block with the letter will have a Velcro strip attached to it, and it sticks to the bottom. And you can pick it up and stick it right top here to spell these words. So the manufacturing process was a bit complicated, right? So we did carpentry woodworking, and we actually had to cut out every individual slot, every individual piece, and glue it all together and screw it together. And it was a long process. It was a long process and a timely process. And it took a lot out of us, and it took a lot of energy to put into this project. So after we individually cut all the components, we cut just basic square shapes for this thin square shapes for the screen and the keyboard, right? And then we glued everything together. We attached the screen and the base, or the keyboard, quote unquote keyboard, with a hinge so it can open and fold as intended. And then we attached the mouse with a string. We just attached it with a string with some super strong Gorilla Glue. And again, the mouse has no aspect on the toy itself. no impact on the toy itself besides aesthetics. So here's the ASTM tests. This is kind of what we were talking about earlier on. And so we have the sharp edge test. This was what we were talking about earlier. So we have the sharp edge test. So basically the sharp edge test just states that you have a towel with this material that we were given, and you run it across the edge. And if it cuts that material, it is not safe and it is a risk to harming the human hand or child's hand or anybody's hand. So that means the safety test would not pass. However, ours passed. There were no cuts on the material on the wooden dowel. And then we had the drop test. We dropped it from about a height of 3 to 4 feet, give or take, to impersonate the height of a child around 3 to 5 years old, right? So, or a little bit taller than that height, because we want to make sure that this is safe. And it passed the drop test. It didn't break. And another test is the choking hazard. This was a main concern for us. And however, the choking hazard test states that the blocks have to be above, or the blocks have to be larger than 1.25 by 1.25 inches. And our wooden blocks are 1.5 by 1.5 inches. And then the compression test. We applied about 5 pounds of pressure for this in a bunch of different angles in a bunch of different ways, and it passed. And even I know you guys are probably looking at this like, what is this waffle maker looking thing? This waffle thing. It looks flimsy, but I promise you it's not. It's a computer. It's very stable. The hinges are on there very securely, and we cannot get this thing to budge. It is extremely safe for the market. So our path forward, obviously, improve the overall manufacturing process. It was a mess trying to get the hinges and everything. It was a mess. I'm sorry, to get the slots evenly and to cut out every individual slot. It was very time consuming and it took a lot of energy out of us. And we realized we probably could have done it in chunks and saved a lot of time. And then we want to improve the design function and flexibility. And all this is saying is we were kind of not we were very satisfied with this, but not as satisfied because as I showed you in the CAD design, we wanted it to look like a computer where the screen and the base is connected. However, the wood was much more difficult to work with than we had originally had anticipated. So this is the hinge is a little bit raised in order for this to flap down, and in the future, we would have to find a smaller hinge and find ways to work around this hinge problem to make it look a little bit more like a computer. And again, that goes hand in hand with looking more like a computer. All right, so I would like to acknowledge my amazing team members I was able to work next to in this project. Raj, Ryan, and Nick. I did not know them going into this semester, and now I consider myself very good friends with all of them and people who I can trust. And a huge thank you and shout out to Professor Buckley. She did an incredible job managing of all of us as students and all of these projects. And she and the whole mechanical engineering department here at the University of Delaware did a great job in supporting us, assisting us, and managing us. And then obviously a huge shout out to Melissa and Doug, our sponsor and our inspiration for this toy design and the inspiration for these hundreds of students, hundreds and thousands of students over the years to create these wooden toys. A huge shout out to them. I hope you enjoyed the Learn to Spell wooden computer with blocks, and thank you for listening.